Hello students. Today's topic is alcohol. So in alcohol we have to discuss certain things, that is preparation reactions, that is from which compounds we are gonna prepare alcohol, that is one thing. And then comes our uh, properties of alcohol, and then our reactions of alcohol, that is preparation reactions of alcohols. So first is from our alkenes. Okay, so we can prepare the reaction by concentrated H2SO4 and giving it heat, and in second step giving it H3O plus. That will be a one reagent. Then we can use another reagent, and that reaction will be called hydroboration reaction. So the reagent will be in first step B2H6 THF H2O, that is our water, and second step we will give NaOH and hydrogen peroxide, that is our H2O2. Now there is another reaction that is called oxymercuration demercuration process. So here the reagent will be THF H2O and Hg CH3C double O whole twice NaBH4. So let us see an example here, that is if we take this alkene here, and in it questions they will give you three of them, that is our concentrated H2SO4. Also they will give you B2H6 H2O2 like this, and in second case oxymercuration demercuration they will give THF H2. Now, and also what is the reagent here, that is our Hg CH3 C double O whole twice O. Now as you can see that these three reactions give our what, alcohol, but there is a certain trick here, that is when the double bond will be opened, okay, the plus sign will come here, but as you can see that this is 3 degree carbon atom and this is 2 degree carbon atom, so the uh, hydrogen shifting will happen here, so that's how here a 3 degree carbocation will be formed. So this hydrogen will be shifted here. So what will it give after hydrogen shifting, that is it will come like this. Now in the first case, in concentrated H2SO4, the OH group will be added here. Okay, so let's add OH group here, that is here. So that's how in the first case it will come. Now in second case, where the reaction is called hydroboration reaction, what happens, that this carbocation will be formed here, because this is our added in anti-Markovnikov rule. Now you are thinking what is Markovnikov and anti-Markovnikov. So for that you have to see our anti-Markovnikov and Markovnikov video. So if this is added in anti-Markovnikov rule, so what will be the OH added, that will be here, it will be added, right? So but in the next case, this has gone Markovnikov, this has gone anti-Markovnikov, but what will happen in the third case, That is, in the third case, if we just draw the simplest carbocation that came, that is this without hydrogen shifting, so the OH will go and add to the first carbon cation where it is formed. That means it the hydrogen shifting will not happen here, and the OH will be added just simply here. So this is the distinction between the three reaction, that in the first reaction it will be added like Markovnikov rule, in second reaction it will be added like anti-Markovnikov rule, and in the third reaction it will be added in the carbocation where it is formed first. Okay, so let's see. That is, next is from carboxyl compound. Now what is carboxyl compound? Carboxyl compound are aldehyde and ketone. Okay, so this is our carboxyl compound. Now in the is the first reaction, and second is our PDH2, then is our NaBH4. Now here is a slight distinction, that is, in case of our LiLH4, let's see an example that it gives our alcohol like this, that is the OH will come in place of this double bond and extra H will be added here. Okay, and this reagent also can, what I can say, that is, and this reagent also converts our acid into alcohol. Okay, and this PDH2 also does the same thing. Okay, so I'm writing it here same, but in case of NaBH4, it converts our aldehyde and ketone into what? Alcohol. But in case of our carboxylic acid, it doesn't convert it into alcohol. So if we take an example here, as you can see, so if we give it what? This NaBH4, as you can see, what I have told you, this double bond will come OH, but there will be no change in this acid group. Okay, so that is how we distinct NaBH4 reagent. Now let's see a special reaction here, that is Meruy-Pondov-Vanle reduction. Now what does this Meruy-Pondov-Vanle reduction does? That is, if we have a mixture of a ketone plus the respective alcohol, that is our this, because if this ketone is converted into alcohol, it is from this alcohol. So if we have the mixture of these two and we give this Meruin-Pondov reagent, so what will it give us? MPB reagent we call it. So it converts the whole solution into this alcohol. Okay, so you have to remember it, that in the question they will give you two of this, and they will also give you this MPB reagent and ask you what will be the final product. So the final product will be this alcohol. Okay, so let's see next. That is from carboxyl compound. As I have told you, that from if we want to convert carboxylic acid into our alcohol. So the reagent will be our LiLH4. So let's see an example again. So if we give it LiLH4 in place of double bond O, OH will come and the extra H2 will be added, nothing more. Now there is from alkyl amine. So what is alkyl amine? That is, if a amine group is added to a alkene in place of its one of its hydrogen. So let us take this example here. So if we give this reagent here, okay, so it gives us CH3 CH2 OH. That means in place of NH2, the OH will be added. Okay. Now here is from ester to alcohol. Now from ester to alcohol, there is a special reaction that is called our Van Bolt-Blake reaction. Okay. So what is Van Bolt-Blake reaction? Let's see. Let's see what is ester first. That is, this is a ester. We'll study it in our carboxylic acid chapter more frequently. So let's just see here. And if we give it this Na plus and ethanol, what will be the product? This bond breaks. Okay. So in place of this double bond O, it comes OH and the respective H2 will be added here. And in this whole gives another alcohol, that is this. So that's how this Van Bolt-Blake reaction occurs, and ester forms these two alcohol. Okay. So let's see some properties of our alcohol. That is our boiling point. That it depends on the surface area and the molecular mass. With the increase in the hydrophobic part length, the boiling point increases. That means if we have a alcohol like this, okay, so it will have more boiling point because this chain length is increasing. So hydrophobic part is increasing, so the boiling point is also increasing. But there is also another factor, that is our surface area. So that means this simple chain will have more boiling point than this what, branched alcohol. Okay. So that's how we decide our boiling point of alcohols. So let's see the next property, that is our solubility. That is, alcohol is soluble in the water because they are forming hydrogen bond in the solution. Okay. But here also, as we know, the boiling point is inversely proportional to solubility. So here this will have more solubility than this simple chain alcohol. Okay. Now let's see some reactions of alcohol. That is the reaction with Na metal. So what happens if we react it with our Na metal? That is, the OH will be replaced with our ONA. Okay. So it gives us ONA like this. So many of you are thinking how this came. That is, our H and O, there is a bond, so it will be broken and Na replaces the hydrogen. Okay. So what will be formed with the sodamide? Now in case of sodamide, same thing occurs, that is CH3 CH2OH If we give it NaNH2, so it again forms CH3CH2O Na. Okay. Now there is our oxidation reaction. So in oxidation reaction, that is if we have this and if we oxidize it, then what comes? It gives us carboxylic compound like this from CH3CH2OH. If we oxidize it, it gives us CH3CHO. Okay. Now let's see, that is our identification reaction. Now what is identification reaction? Identification reaction is how we separate alcohol and other our molecules, that is our ester, ether. Okay, how we separate them and identify what kind of alcohol it is. That means 3 degree, 2 degree, or 1 degree. What kind of alcohol it is, that we decide in this identification reaction. Now first is our iodoform reaction. In iodoform reaction, you have to remember one thing, that is, to iodoform reaction occur, there has to be this group, that is CH3C double bond O. Okay, so if this group uh, is present in our uh, iodoform reaction, so it will occur, and if it is not present, iodoform reaction will not occur. Now this group can be present in aldehyde, ketone, alcohol. Now in alcohol, I am going to tell you how you are going to see this group, because this group can be present in alcohol, but if we oxidize the alcohol, this group can be found. So we have to just assume that. So let's see what will be the reagent of this iodoform reaction, that is iodoform. So they will give you I2 and also NaOH. Okay, so if we take this alcohol here, that is CH3OH, so you can see if we just oxidize it, what does it give us? It gives us HCHO. That means it doesn't have this group what I have told you. But if we oxidize this group of alcohol, that is our ethyl alcohol, what will it have? It will have this group, right? So this will be react in iodoform, and what will it form? That is it gives our CHI3, and this will form yellow PPT, or we can specifically say golden yellow PPT. Okay. Now there is another test for differentiating 3, 2, and 1 degree and alcohol. So what is that? That is our Lucas test. Now what we have in Lucas test, that is our anhydrous ZnCl2 dissolved in concentrated HCl. Okay, sometimes they just give you these reagents and you have to remember that it was from our Lucas test. Okay, so in Lucas test, if it is 3 degree alcohol, so it just becomes turbid instantly. Okay, instantly it will be turbid. So what is turbid? I don't know you if you have seen that if we just mix a limestone in the water, it forms a what I can say foggy or that kind of solution. So that is called a turbid solution. So it will be turbid instantly. If it is 2 degree, then it becomes turbid, but after 5 minutes. Okay. and in 1 degree it doesn't become turbid. Doesn't become turbid. Now there is another test, that is our Victor Mayer test. Now in Victor Mayer test, there is two alcohol can participate. That is our primary alcohol and secondary alcohol. So what is the alcohol that can be participating here? That is our tertiary alcohol that can participate in Victor Mayer test. So if the Victor Mayer test is negative, so you can just guess it is our tertiary alcohol or 3-degree alcohol. Now, how we differentiate it is primary or secondary? That is, if it is primary alcohol, then in Victor Mayer test it gives our red color, and if it is secondary alcohol, then it gives our blue color. So that's how we just differentiate it. Okay.